Very good morning. Let us continue our learning of the subject discrete mathematics, meant for semester 3 students of computer science and affiliated branches. This is our syllabus, and today's target of discussion is sets, set operations, and related Venn diagrams. The contents for today's deliverable are derived from textbook called as Discrete Mathematics and Its Application, 7th edition by Kenneth H. Rosen. This is a prescribed syllabus book, as you can see, Kenneth H. Rosen, McGraw-Hill publication. So let us continue learning today's topic, that is sets, set operations, and Venn diagrams from Unit 1. So when I say a set, I can say a group of students, bunch of keys. So mathematically such group, such bunch is called as a set. Set, what exactly is a set? Set is a collection of objects. Set is a collection of well-defined objects. Set is a collection of distinct objects. So objects are distinct, objects are well-defined. And this set is unordered, so there is no ordering. So the members of the set or the objects of the set are called as elements or members. Set is represented using capital letters, and set elements or members are represented using small letters. How do I represent set? There are different methods of set representation. The first method is description method. Say I can say like this: A is equal to curly braces, set of all odd numbers up to 10. The second set representation method is roster method. Say for example, here we are representing vowels A, E, I, O, U. So V, here V is a set. This set consists of the elements A, E, I, O, U. So all the elements, all the members are separated by comma and enclosed in curly braces. So in the roster method. So you can see here O. O is a set, okay, and it is represented using roster method, which has a curly brace, and the elements or the members are separated by commas. So what is O here? O is a set consisting of odd numbers up to 10. The third method for set representation is set builder method. So here set builder method has some rule or some formula which will specify who can be the member of the set. Say for example O here. O is a set. It consists of X. But what is the rule for this X? X is an odd positive integer less than 10. Similarly, O is a set. It consists of X and X belongs to Z plus, and X is odd and X is less than 10. So Q plus is a set where X belongs to R, X is equal to P by Q for some positive integers P and Q. So few famous representation in sets are N are natural numbers, Z are set of integers, Z plus are positive integers, Q are rational numbers, R are real numbers, R plus are positive real numbers, C are the set of complex numbers. Now, equality of sets. How do I say two sets are equal? Okay, if the elements or the members of A and the elements and members of B, these two being two different sets, are equal, then we say these two sets are equal, and we can write it as A is equal to B. So A is a set, B is a set. So, and both of them are having same members. Say for example, members are X, okay. So for all X, X belongs to A implies X belongs to B. Say for example, here set A is 1, 3, 5. Set B is 3, 5, 1. Are they equal? Yes, they are equal because set A consists of 135, set B also consists of 135, but the order is different, and as the definition of set indicates, order is not important. They are unordered element, but they are similar elements. Even if you can say that 135, this set and this set, which is having 1 3 3 3 3 5 5 5, are they equal? Yes, they are equal because we are considering the distinct element. We are considering the distinct element. So equality of sets indicates both of them should have the same elements, irrespective of the order, irrespective of the number of times they are repeated. The next type of set is an empty set. The empty set is also called as a null set. The null set is denoted by 5. The null set is denoted by 5. And it consists of 0 elements. Suppose a null set is there, you just have an open curly brace and close curly brace. It doesn't have anything. Suppose you have like this. There is an open curly brace inside 5 and close curly brace. It doesn't mean it is an empty set. It actually means it's a singleton set. Okay, so which has one element, that element is 5. Okay, you can represent sets with the help of Venn diagrams graphically. Okay, so Venn diagrams were given by John Venn in the year 1881. So the universal set in Venn diagrams is indicated by U. It consists of all the elements, and the universal set is represented by this rectangle. So this is the Venn diagram representation. So how we are representing Venn diagram? This rectangle indicates the entire universe. So this universe is indicated by U, and inside you have circle. Inside you have circle. Okay. So these circle will be indicating a set. For example, what this circle is indicating? This circle is indicating a set consisting of vowels A, E, I, O, U. So represented by V. So the name of the set here is V. V is a set which is part of this universe. This is how you will be representing your Venn diagrams or sets with the help of Venn diagrams. Now, here I can also elaborate the definition by saying that V is a set consisting of ovals, but what is U? U is the universe consisting of all the letters. All the letters means alphabets. So 26 alphabets. That's how you represent this. So what is a subset? Subset is denoted by this symbol. A is a subset of B. Okay, when A is a subset of B, if every element of A is also an element of B, then it is a subset of B. So for all x, x belongs to A implies x belongs to B. Now, here, using this Venn diagram, what we are showing, A is a subset of B. A is a subset of B. So how I can show that? Okay, all the elements of A belongs to elements of B, belongs to B. If I want to show A is not a subset of B, then I have to find out at least one element, one member of A which is not a member of B. Now, how do I say two sets are equal? Okay. To show that two sets A and B are equal, we have to show that A is a subset of B and B is a subset of A. Okay. Say for example, I have a set like this. A. A consists of this 1, 2, 3, 4 subsets. And I have a definition here like this. B consisting of X, and X is a subset of the set A comma B. So that's why these two sets A and B are equal. Okay. The size of the set. So let us say S is a set and S is a finite set. Then N is the cardinality of the set. The cardinality of the set is denoted by this symbol. So we'll just find out here. Let A be a set of odd positive integers less than 9. So less than 10 rather. So what are the odd positive integers? 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. So total 5 number of elements are there in this set A. So the cardinality of A is 5. So let S be the set of letters of English alphabet. So the cardinality of S is 26. The null set or the empty set has no elements. So the size of the empty set is 0. Coming to the next definition, power sets. Let us say S is a set, then this symbol P of S indicates the power set. Okay. What is power set? It is set of all subset of the set S. It is set of all subset of set S. Let us say this is my set. This set consisting of 0, 1, 2, 0, 1, 2, 3 members. How do I find the power set of this? I have to find all the subsets of this. Okay. So how do I represent that power set? So first there is an empty set, then 0, 1, 2, 0, 1, 0, 2, 1, 2, 0, 1, 2. So all the possible combinations we have listed out. I'll just count the number of combinations. 1, 2, 3, 4, 5, 6, 7, 8. So how many elements are there? 3. So 2 cube. So 2 to the power of n. Power set is always represented by 2 to the power of n. So here you can also see that the empty set as well as the set also is the part of that subsets. Now, if somebody asks you what is the power set of the empty set, okay? So the empty set has only one subset, namely itself. So the set has two subsets. This set has two subsets, namely phi and the set phi itself. Therefore, the power set of this empty set is represented by phi comma set of phi. Now let us try to understand what is a Cartesian product with an example. Let us say set A consists of 1, 2. Set B consists of A, B, C. The Cartesian product of A and B is so 1, A, 1, B, 1, C. Then 2, A, 2, B, 2, C. So the Cartesian product of A and B and the Cartesian product of B and A are not equal. Say for example, if I want to take the Cartesian product of B and A, what will be the Cartesian product? A, 1, A, 2, B, 1, B, 2, C, 1, C, 2. So this is it. So I can see here that Cartesian product of A and B and A are different. So how do I define the Cartesian product? Okay, it is set of all ordered pairs A, B, where A belongs to set A and B belongs to set B. This is how I represent Cartesian product. Cartesian product has A, B, where A belongs to A and B belongs to B. So suppose I want to find the Cartesian product of A, B and C where A is 0, 1, B is 1, 2, C is 0, 1, 2. How do I proceed? So this is what is 0, 1, 0, 0, all the possible combinations. So let us go for the next topic, that is set operations. The first set operation is union of set. The union is indicated by this symbol. So A union B is defined as like this. What is the definition? A union B, it contains those elements that are either in A or in B or in both. Okay. So suppose X is the element. X belongs to A or X belongs to B. And the Venn diagram to represent A union B, you can see the entire shaded figure, which can say that the elements are part of A, the elements of part of B, or elements of part of both of them, A and B. So say for example, I have a set called as 1, 3, 5. There is one more set 1, 2, 3. Okay. The union of these two will be, what is the definition here? That are either in A or B or in both. So 1 is there in both, take it. 3 is there in both, take it. 5 is there in A, take it. 2 is there in B, take it. So all the elements we have taken. Coming to the next definition, intersection. Intersection symbol is this. And what is the definition of intersection? It consists elements which are both in A and B. So this is definition. A intersection B consists of element X such that X belongs to A and X belongs to B. And this is the Venn diagram. You can see the shaded part here. Suppose 1, 3, 5 is one set, 1, 2, 3 is one set. So what will be the intersection which contains both in A and B? So 1 is A in A and B. 3 is in A and B. So naturally, the intersection of this A and B will be 1, 3. Two sets are called as disjoint sets if their intersection is empty. Basically, disjoint sets means no elements are common. Say for example, set A consists of 1, 3, 5, 7, 9. B consists of 2, 4, 6, 8, 10. By looking at this only, we can understand that there are no common elements. If I find the intersection of A and B, the intersection of A and B is 5. Hence, A and B are disjoint. And how do I represent this? A union B. A union B can be represented as A plus B minus A intersection B. Let us say A and B are two sets. The difference of A and B is denoted by A minus B. It contains those elements that are in A but not in B. The difference of A and B is also called as the complement of B with respect to A. See the Venn diagram here. So A minus B means elements which belongs to A, okay, but which are not in B, but which are not in B. And A and B is represented as X. It has element X such that X belongs to A and X does not belongs to B. Say 1, 3, 5 and 1, 2, 3 are the two sets. What is the difference? Belongs to A, does not belongs to B. So such element is only one, that is 5. That's why the difference is 5. Now, what is the complement of A? The complement of A is denoted by this A bar. Okay, and it is given as U minus A, where U is universal set. And complement of A is X belongs to U and X does not belongs to, such that X does not belongs to A. See here, this is the definition of complement of A in the Venn diagram representation. How? Because this is A and I have shaded this U part, means this is the complement of A part. Suppose A consists of ovals. A is a set consisting of ovals A, E, I, O, U. So what will be the A bar means complement of A? All the alphabets other than this A, E, I, O, U. So difference is indicated by A minus B is A intersection B bar. Similarly, complement, one more example is there here. Suppose you have a set A which consists of all positive integers 10. Then, greater than 10. Then complement of A will be all the elements which are less than or equal to 10. So 1 to 10 will be the members of that. Okay. So let us stop here our discussion of set theory and set operations, including the Venn diagram.